All right, we are going to move on and talk about day 30 in chapters 11, 14, and 15 for AP Statistics. What I have up here on the screen right now is a review of what we covered last time. And just to summarize the steps for a simulation, what we're talking about is simulating a situation and trying to create a probability using that simulation, the probability that something will happen. So there are 7 steps for a simulation. They're a little modified from the book. So the first step is identify the component to be repeated, explain how you will model the outcomes, explain how you will simulate the trial. A trial or run is the sequence of events that we pretend will take place. State clearly what the response variable is. Give one example and run several trials. The more trials you run, the more precise your estimate will be. Analyze the results. This is usually accomplished with a table or graph of the response variable. And state your conclusion in the context of the problem. So we're on day 30, and what we're going to look at is a situation dealing with getting parking spots at a school. And so the student council, they're called the STUGO. And this is day 30. We're going to estimate, use simulation to estimate probabilities. Suppose that there are 150 seniors at a particular school, including 19 members of STUGO. They signed up for senior parking, which gives each student the right to a particular parking space close to the campus for the year. Also, suppose that each student's spot is determined by a lottery. The student body became suspicious, however, when STUGO members were awarded 5 of the 10 best spots. Is this suspicion warranted, or could this have occurred by chance? The main thing we're trying to show or not show in our simulation is that it could or could not have occurred by random chance. So we want to conduct a simulation to estimate the probability of STUGO members getting at least 5 of the 10 best spots, assuming the lottery is fair. So we're going to go with the assumption. We're going to assume the lottery is fair. And we want to find the probability that STUGO members get at least 5 of the 10 best spots. You want to find the probability that STUGO members get at least 5 of the 10 best spots by random chance. So that's what we want to find. We're assuming the lottery is fair. So step 1, component to be repeated. All right, the component to be repeated here is award a parking spot to a senior. That's the component we're repeating. We're awarding a parking spot to a senior. We're going to reward 10 parking spots to 10 seniors by drawing their names, or actually their numbers, out of a hat. So how will I model this? Okay, the way I'm going to model this, there are 19 STUGO members and a total of, 19 STUGO and total of 150 seniors. I'm going to use random digits. From 001 to 019 will be STUGO, and from 020 to 150 will be non-STUGO. So in other words, I'm going to use a random digit table, or I could use my calculator, and I'm going to select 10 seniors to get parking spots. So 3, how do I model a trial? Okay, we will select 10 random numbers from 0 or from 1 to 150 without replacement. What does that mean, without replacement? It means that I'm not going to use the number 25 twice. I can't award one person 2 parking spots. You can technically only drive 1 car to school yourself. Okay, so we will select 10 random numbers from 0 to 150 without replacement to represent the 10 seniors who get the best spots. All right, so for response variable, this is really the key. This is very important that we can name what is it that we're trying, what information are we trying to get from doing all this up here. So the response variable, what we really care about, remember we were trying to see if this was fair. And the Stugo members, they got half of those good spots. And we want to see what's the probability that they get half or more of those spots by random chance. So the response variable is related to what we're trying to figure out. So the response variable, we will count how many of the 10 people selected were in Stugo. So in other words, from the numbers 1 to 19. So 5, here's an example. So I'm going to use my calculator. So I'm going to go math, PRB, random integer, and I'm looking for random integer, no repeat. I don't know if that's going to work. So we're just going to do random integer, 1 comma 150, and I want, let's see if it'll give me 10 of them. Yep, it did. So I just need to look at them and see if there's any repeats. Probably best if I just write them down. So here's my example. I had 142, 137, 23, 78, 61, 111, 7, 51, 150, and 31. It looks good. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's my first trial. There are no repetitions in there. So how many of those were Stugo members? That would be any number from 1 to 19. There's 1. So 1 of the 10 was in Stugo. There's my example. All right, so what I want to do is I want to run some trials now. So that's an example of a trial. And so I want to run, if we were all doing this in class, we would run a bunch of trials. But let's just say I'm going to run 10 trials. All right, so I did 10 trials in addition to my example. And what I did was I just used my math over to PRB. And I went down to, whoops, I went too far. PRB, and then I went down to number 5, random integer. I told the calculator I wanted numbers from 1 comma 150, and then comma I wanted 10 of those, and I hit enter. And then I didn't go up and highlight it, I just moved the arrow over, and that would move me so I could look at all the numbers and write them down. And I wrote down all of my trials, which is what you should do on your homework. And then the key thing, remember the response variable, what we were looking for is we will count how many of the people selected were in Stugo. So how many of those were from 0 or from 1 to 19. So that's what I did. In each of my trials I counted, and at the end I have these are how many of the people were in Stugo. So the highest one I had was 4. So now I need to look at step 6. I need to look at the results. And usually a dot plot is something nice, so the number of Stugo selected 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because I could have actually selected all 10 people. So in my trials, in trial number 1 I had 3 people, and in trial number 2. And in trial number 3 I had 1 person, and then 3 again, and 4, and 1, and 1, and none, and none, and 2. So there's a dot plot, and as I can see, the probability is actually, the formula for probability is the number of favorable outcomes over the total possible. Okay, so of our 10 trials, we had 10 trials. How many of them had what we desired? What did we desire? The favorable results, we desired that greater than or equal to 5 spots were to Stugo. So by random chance, how many trials had 5 or more spots given to Stugo? None. None of our trials had 5 or more Stugo members getting those spots. So by random chance, there is 0 probability that at least 5 of the best spots are given to Stugo members. Maybe a better way to say that, there is a 0, the probability that at least 5 of the best spots are given to Stugo members is 0 by random chance. The probability that Stugo members get at least 5 of the spots by chance alone is approximately 0. So we have convincing evidence that the lottery is not fair. All right, so we'll have another simulation example that we'll do in the next video.